want to see what will happen if you want to get the electric field at a point due to a negative charge. So the negative charge Q is the source charge, and we want to go to a point P in space here and get the electric field at that point. So as we said before, to get the electric field at a point, we need to bring a test charge. So the test charge Q node is the test charge we're going to use to find the electric field at that point. So the point P is where the charge Q node is located. Now the unit vector that points from Q to P, again we write it as r hat QP, and the distance between the two points, point P and the point where the charge Q is located, is rQP. And of course, since this now is a positive and a negative charge, the force on charge Q node will be towards the negative charge. So this will be the force on charge Q node. And we can write the force as a vector, the same way we did before. The force on Q node due to charge Q is KEQ Q node over r squared r hat, and Q and Q node have to be put with their signs. If you want to define the electric field at point P, the definition is it's the force on the test charge that we had at point P divided by the value of the test charge, Q node. So when you divide the force by Q node, the Q node goes and you are left with KEQ over r squared r hat, which is exactly what we had before. So the only difference, and we'll see right now, is with the case of a negative charge, is when you get the vector, the electric field vector at point P, remember, we have to put the charge here with its sign. So put the charge here with its sign, the charge is negative, the charge Q is negative, so you put minus magnitude of Q. Now this minus sign indicates what? It indicates that the electric field vector is not in the same direction as the r hat QP vector, it's opposite to it. And so that means that the electric field vector, due to a negative charge, it doesn't point along from the charge to the point where you want to find the electric field, it points opposite to it. So that's why you see here these electric field vectors are pointing towards the negative charge and not away from it. And that the reason for that, again, is because of this minus sign. This quantity is all positive, and this quantity is in the direction opposite that going from the charge to the point, because r hat QP goes from the charge to the point. That means minus r hat QP is opposite to it. So the electric field due to negative charges the vectors point towards the negative charge. And the same thing has happened before. When you're close to the charge, the electric field vector is large, value, magnitude. And when you go away from the charge, the electric field vector gets weaker and weaker as you go away. And that's because of the 1 over r squared dependence. The direction is given by this part of the expression.